Hello everyone. In this video, we will discuss about acid-base theory. On the basis of different theory, how we can define the definitions of acid and base, we will discuss in the present video. Now before going to discuss in detail, now we will discuss what are the learning outcomes of the present video. So after studying this lecture, you shall be able to understand the difference between definitions of acid and bases, identify acids, bases, conjugate acid-base pairs according to the definitions of acid and bases. You can also understand the concept of conjugate acid-base pairs in acid-base reactions. Now, in our daily life, we are seeing that we have various acid and bases in our daily life. That we have vinegar, in which we have acetic acid. We have lemons, like citric acid. We are using different compound. We have tartaric acid in this case, like we have antacids in the milk of magnesia. So these are some of the products in which we have daily life acid-based products. We have utilized also in household cleaning products like ammonia in this one, washing soda in the powder, and we have also hydrochloric acid present in the gastric juice, which is secreted in our stomach, which is essential for digestion of our food. Now come to the Arrhenius concept of acid bases. According to the Arrhenius theory of acid and bases, which is given in the 1887, acids are the substances which contains the hydrogen and give rise to H plus ions in aqueous solution are known as acid. As we can see in this reaction that it is the HCl which is referred to as strong acid. When it is dissolving in the water, so it is dissociated into ions H ion aqueous plus Cl negative ion aqueous. So that's why this is giving the H plus ion in the aqueous solution, that is referred to as acid. Similarly, we are taking the acid, that is the acetic acid, which is referred to as weak acid. So it is also dissociated, but it cannot easily release the H plus ion in the solution. Now, acidic property is mainly due to the presence of H plus ions. So according to the RNA that described that H ions in water are the bare ions. But H ions has very small size and they are having high charge density. Therefore, they can readily bind to the water molecule. In this case, they can readily water and they can form the S3O plus ion, that is referred to as hydronium ion. But for the sake of convenience, we can write it as H plus ion. Now let us discuss how we can define base. So basically base is a substance which contains OH group and produces the hydroxide ions, that is OH minus ions in the aqueous solution. As we can see reaction that NaOH, when it is in the aqueous form, it dissociates into Na ion aqueous plus OH ion aqueous. So because it is giving the OH ions in the aqueous solution, that's why it is referred to as base. Similarly, in case of NH4OH, that is ammonium hydroxide, it is also dissociated ammonium aqueous plus OH minus, but it is not giving easily the OH ions in the aqueous solution, that is referred to as the weak base. Now, according to RNA theory, neutralization reaction is defined as the reaction in which H plus ions forms acid which combines with the OH ions formed from the base, and they are forming the salt in the reaction in the form of undissociated molecule water, that is called, in this, as we can see in the equation, that acid is strong acid, this is strong base, they are forming the salt along with the undissociated water molecule. In this case we can say when they are dissociated into ions, so these Cl, Na ion and these will be cancelled with each other, we will get only undissociated water molecule in the reaction, that is called as neutralization reaction. What are the limitations of the RNA theory? According to RNA theory, it is only applicable to the aqueous solutions. And second limitation is that RNA theory does not account for the basicity of ammonia, Na2CO3, etc., which don't have OH negative group. That's why this theory failed in this case. Now let us move to another theory of acid-base theory, how we can define acid and base on the basis of this theory. So second theory is the Bronsted-Lowry acid and bases, and this theory was proposed by the Bronsted-Lowry in 1923. According to this theory, Acid is the substance that donates the proton H plus ions to the another substance that is called as acid, while base are the substances that can accept proton from the another substance that is called as the base. As we can see in this section that HCl plus ammonia, when they are reacting with each other, they are producing the NH4 ion plus Cl ion. In this case, this is the acid one, and when it is the donates the proton, in this case, so it is forming the base after proton, and this is accepting this one. So in this case, this is the reaction is reversible. That's why if we are taking a reverse side, so this ammonium ion can donate the proton ion and forming the this base molecule, while in this case this can accept the proton, it is forming the HCl. So in the reverse direction, this is the acid, this is the base. Now in this case, HCl acid one, it is giving the H plus ion to this one because base can accept the H ions, so that's why they are forming the NH4 ion, and it is because HCl is giving the H plus ion, so they are releasing only Cl negative ion. So in this case, this is, but if we are taking the reverse, so in the reverse reaction that Cl negative ion can accept the H plus ion that is forming the this HCl. So in this case, this is called as base, while it is acid. Or similarly, ammonium ion can donate the H plus ions in the reverse section forming the NH3, that's why it is referred to as acid. So here HCl and ammonium ion the proton donor which is act as the acids. Now if we discuss about ammonia and chloride ion, so both are proton acceptor, acts as a base as we have discussed in the previous slide also. And according to RNA acids, RNase acids are also called as bronze acids, but RNase bases cannot be bronze bases, as we can see in reactions that HCl, it can donate electrons, it can donate the protons, that's why it is forming this one. We have HCl plus H2O liquid is producing the H3 ion plus Cl negative ion, but in this case, if we discuss about base, so according to Arrhenius, base are the substances which can dissociate into OH ions in the aqueous solution. So here it is in this case, according to the bronze state, that can accept the proton, that is called as base. But according to Arrhenius, that give OH ion in the aqueous solution, that is base. So here RNA acids can be represented as bronze state because according to bronze state, H ions can be given by acid or RNAs when it gives in the H ions in the solution. That is called as, so both are same. That's why we can say RNase acids are bronze acids, but RNase bases are not the bronze bases, as we can see in these reactions. Now, what are the products of Bronsted Lorry acid-base reactions? Are basically these are acid and bases. So, if we discuss about the pair of an acid and base, which is differing by a proton, it is said to be a conjugate acid-base pair, as we can see here that if we are taking this reaction NH3 plus HCl, it is producing the NH4 ion plus Cl negative ion. So, in this case, this NH3 and NH4 ions are referred to as conjugate acid-base pair because this is base when it is accepting a proton according to Bronsted-Lowry, so it is forming the acid in the further product, while so this is the base, and after accepting proton, it is forming the conjugate acid. Similarly, HCl is acting as an acid in this reaction, and when it is donating the H plus ion to another base, so it is forming the Cl negative ion base. So HCl is here, it is the acid, while Cl negative ion is the conjugate base for this HCl. Now, if we are discussing another example, H2SO4, H2O, in this case, we are getting HSO4 minus ion plus H3O plus ion. So, in this case, this H2O, it is the here Bronsted-Lowry base, while it is accepting H plus ions, it is producing the H3O ion plus, that is called as conjugate acid of H2O. While similarly, this sulfuric acid, that is H2S4, is the Bronsted-Lowry acid, and when it is donating the H plus ion to this H2O, it is producing the HSO4 ion species, which is conjugate base of this H2SO4 species. The base produced by the accepting the proton is from an acid is the conjugate base of that acid Similarly, if we are taking the various example, suppose we have acid HCl, this base, conjugate base will be Cl negative ion. If we are having HBr, conjugate will be Br negative ion. If we are having HNO3, then its conjugate base will be the NO3 negative ion. If we are having this acid, we are having, this is the conjugate base of this species. Now, the acids produced when base accepts a proton, which is called as conjugate acid of its base. Similarly, as we can see in this following examples, these are the base species and these are the conjugate species of these bases. Like suppose we are taking the ammonia as a base, when it is accepting a proton, then it is producing the ammonium ion, which is the conjugate acid of this ammonia base. Similarly, if we are taking another example, that is OH minus ions, in this case also, that it after accepting proton it is forming the HOH. So in this case this HOH species will be the conjugate acid of this OH negative ion base. Let us take another example. This H2O, it will act as a base. When it will accept a proton, then it will produce the H3O ion plus. So H3O ion, that is hydronium ion, is the conjugate acid of this H2O species. And in this case of CO3 2 minus ion, which is acting as a base, then it accepts a proton, so it will produce the SCO3, that is minus, that is bicarbonate ion. This bicarbonate ion will act as a conjugate acid for the carbonate ion. Now let us question example that write the conjugate acids for the bronzite Lorry conjugate bases. So suppose we have, these are the conjugate, these are bronzite Lorry bases, like we have NS2 negative ion, S2 4 negative ion. So base are the species that can accept a proton to form the conjugate acid. So similarly, if we are having NS2 negative ion, when it will accept a proton, it will produce a neutral NS3 molecule because it is having minus one third. After accepting H plus ion species, it will get neutral. So this is the conjugate acid, that is bronzite Lorry conjugate acid for the this NH2 minus species, which is the bronzite Lorry base. Similarly, if you are taking another species that is H2PO4 negative, so after accepting proton, it will produce the H3PO4, that is phosphoric acid. So it is the conjugate acid, that is bronzite Lorry conjugate acid of this H2PO4 minus bronzite Lorry base. Now write the conjugate acids for bronzite Lorry conjugate base. Suppose we have, these are the bronzite Lorry acids. So we know that according to Bronstedt-Lowry definitions, acids are the substances that can donate H plus ion to other species. So in this case, this is the hydrogen cyanide. If it is donating the H plus ion to another species, it is forming the cyanide ion. So this cyanide ion will be the Bronstedt-Lowry conjugate base for the this SCN molecule. Similarly, this H2O will act as a acid. After acting as a acid, it will donate H plus ion and form the hydroxide ion, which will, this hydrox OH minus ion will behave as a Bronsted-Lowry conjugate base for this water molecule. Now at last, what are the summary of the present video? In this video, we have discussed that according to RNA theory, acids are those which readily dissociate to give the hydrogen ions in aqueous solution, while alkaline species that dissolved in the aqueous solution to give hydroxide ions, and a Bronsted-Lowry acid is a substance which donates a proton or H plus ions to the other compound, forms a conjugate base, while a Bronsted-Lowry base is a substance which accepts a proton or H plus ions from the other compound, forms a conjugate acid. A Lewis acid can be defined as a chemical entity that can accept a pair of electrons from a Lewis base to form a coordinate covalent bond, while a Lewis base can be defined a chemical species in which the highest occupied molecular orbital, that is HOMO, is highly localized, giving it the ability to donate a pair of electrons. So this is the summary of the present video. These are some of the references that can be utilized for making this video. At last, thank you for your kind attention.